Hello friends, welcome to Shiva Sai for You Basic Electrical YouTube channel. In this video, I am going to provide NPTEL course Network Analysis Week 6 assignment. Okay, question number 2. Solutions for question number 2. So they given a network consisting of inductor, resistor and capacitor. Switch is closed for t greater than or equal to 0. So before that switch was open. Okay. So the given the switch is closed equals to 0. Before that the capacitor was charged. See, before switch was closing, the capacitor was charged to switch closed means t less than 0 means 0 minus. That is 15 volts. And there was no current through the inductor. Under such condition, no current through the inductor. So for t greater than 0, the current I1 of t, I2 of t and the capacitor voltage are expressed like this. I1 of t, A1 e power minus kt sin omega t plus pi 1 and I2 A2 e power minus kt sin omega t plus pi 2 u of t. And Vc of t is AV e power kt minus kt sin omega t plus pi v u of t, where omega is in radians per second and t is in seconds. Pi 1, pi 2, pi v are the radians, such that A1, A2, AV more than 0, such that value of A1, A2, A4, AV more than 0, and the angles pi 1, pi 2 and pi v, pi 1, pi 2 and pi v should lies between minus pi 2 plus pi. So but that is minus 3.14 to plus 3.14. Okay, find the values of the constants A1, pi 1, A2, pi 2, AV, pi v, k and omega. See, first the step is, so I am not going to explain in detail. Okay, you just I'll show the material notes like this. You should copy down and start analyzing. Any doubts you can ask me in the comment box. Okay, so like this. So first step, represent the entire circuit in Laplace domain. What is the Laplace of inductor? SL. What is the Laplace of resistor? No changes. Okay, resistor is 270 only. Okay, and what is the Laplace of the capacitor? 1 by SC. See, 1 by SC. What is the value of C given? 1 by 1620. So therefore, simplification will get 1620 by S. Okay, capacitor. But why I represented this voltage source means, by considering the initial condition. Initially, the capacitor was charged how much? 15 volts. So I represented the capacitor with an voltage source, and that Laplace domain is 15 by S. Okay, got it? So after that, see, when switch is closed, these two are connected in parallel. Okay, this capacitor is delivering the current through these elements. So by adding these two currents, you will get a supply current. So I1 of S plus I2 of S. I1 of S plus I2 of S is equal to, means voltage by this one. What is current in this? Net current. And what is the supply current? Okay, this voltage divided by this entire effective resistance. Okay, that is this one. 15 by S, 1620 by S plus 18S into 270 divided by 18S plus 270, means these two are in parallel. Okay, that combination series with 1620 by S. So like that. So by simplifying this, you will get like this. Okay, I1 of S plus I2 of S, we get like this. So later I1 of S we represented in this manner. Okay, we cancelled this two part. See, please go through this in detail. Okay, so please copy down in a sheet of paper and start analyzing all the steps. Okay, so we got like this I1 of S. Finally, the I1 of S is this much, 0.8333 divided by S plus 3 whole square plus 9 square. Okay, see, this entire can be represented like this. So I want to represent in a Laplace domain. So what I done, I multiplied and divided by 9. See, we should remember this formula. Laplace e power minus at sin omega t is omega by S plus a square plus omega square. So this entire thing applied formula. See, this ratio we got 0.0925 e power minus 3t sin 90 u of t. Okay, see here, you can see the given equation. I1 of t is a1 e power kt sin omega t plus pi 1. Pi 1 is not present here. Okay, a1 e power minus kt sin omega t plus pi 1. Pi 1 is not there. So pi 1 is 0 and a1 is 0.0925. Okay, now similarly I2 of S. See, I2 of S is nothing but you should apply current division rule. Okay, what is the current here? I1 of S plus I2 of S, supply current. By knowing the supply current, we can find the branch current. Okay. So the I2 of S will be, we already got I1 of T. Now I2 will be supply current into inductor divided by sum of this. Okay. Like this you should represent. So I2 of S is entire I1 of S plus I2 of S. This equation means this one. Okay. I1 of plus I2 of S. This is what supply current by multiplied by, okay, opposite resistance, that is inductor opposite. We are finding current in I2, means we need to take opposite parameter, 18S divided by 18S plus 270. This and this will get cancelled. Again same procedure. So keep on solving this. Then finally we got I2 of T like this, okay, in this format. So further we can represent like this. See how I converted from this part to this part. This you should analyze. If you didn't get, you can ask me. I will explain. Okay, I will provide solution how to convert from this to this format. Okay. Later, y means our equation given in the question is a2 e power kt cos omega t plus pi 1. Okay, pi 1 and pi 2. In terms of phase angle, I need to convert it. So therefore, I got like this. Okay, how I written this, you should analyze. Okay, so this entire part, this multiply will get this one, e power minus 3t sine this cos, this entire is cos omega t. Cos omega t is sine omega t plus pi by 2. Okay, so like this. So this is the value of a2, and what is the value of pi 2? This entire thing is pi 2. Okay, sine omega t plus pi 2. Okay, tan inverse 3 by 9 plus pi by 2 gives 1.8925. This value you should enter in the solution. Pi 2 value is 1.8929. Now we got two equations, I1 and I2, we got it. Next finally VC of S. So supply current into, okay, now we need to find this voltage. What is voltage across this capacitor? See, supply current, these two are in parallel. That effective gives something. Current into this, you will get a voltage across this combination. That is what written here. Okay, I1 of S plus I2 of S, that is a supply current into 18S into, those two are in parallel. So numerator multiply, divide, denominator add it, 18S plus 270. So then simplify, we got written that this and this will get cancelled. Again same procedure. Okay, so see this voltage, we got by entire simplification we got 15 e power minus 3t. I thought yes, see they also given voltage, the capacitor initial voltage across the capacitor is 15. Okay, so the same thing we got here also. Okay, but see, take a common factor 4860 divided by all this, you will get this ratio. Later convert it. Okay, because it is in the cos format, I want to convert it into sine, because our equations given in the question all are in sine term, sine omega t plus pi v, sine omega t, like that. In order to obtain in that format, so we need to apply some trigonometric basics. Okay, so how to convert from this to this step? Okay, you should think on that. Okay, so later this into this we got 15.811 e power minus 3t sine 90, and then this is pi v value. This entire thing is pi v. So pi v is also same 1.8925, and AB is 15.811. K, value of K is 3. Okay, value of omega is 9. So we got all the values. By this point numerical will end. See, I will show the entire solution once again. You just copy down in your book, okay, by pausing the video, and later you can analyze. Okay, next is question number 3. So they given a simple, see, very simple circuit, R, L and C. Simple RLC circuit excited by a DC voltage source. The switch is closed at t equals to 0. Before that, the capacitor was charged to Vc of 0 minus is 10 volts. For t greater than 0, the current I1 of t and the capacitor V of t is expressed like this. See, now they given in this format. I of t is A plus B e power minus k1t plus C e power minus k2t U of t. And Vc of t is D plus e power minus k1t plus F plus e power minus k2t U of t. And the magnitude of k1 should be less than magnitude of k2. In this format only we need to represent. K1 value is lesser than k2. This one condition is given, where t is in seconds. If this condition is not given, so students can enter the value of k2 in place of k1 and k2 value in terms of k1, like that. Some confusions are. By referring this condition, you should enter it. And find the values of the constants a, b, c, d, e of k1 and k2. Okay. So now first step, again same thing, representing the entire circuit in Laplace domain. Constants 6 by s, I of t, I of s, 36, inductor 4 for SL, okay, capacitor 1 by 72 farad is there. Laplace domain is 1 by SC, C 1 by S, C is 1 by 72, it becomes 72 by S, okay. And they given here initial voltage before switch was closing, okay, before closing the switch the capacitor charged with 10 volts, so I represent with voltage source. So now apply KVL to this loop, okay. Since we have only one loop, okay, the entire voltage divided by the reactance and resistance in that element gives the current. So 6 by s minus 10 by s whole divided by 36 plus 4s plus 72 by s. So we get like that. So later, see this part, numerator part, simplification you get minus 4 by s and 36s plus 4s square plus 72 by s, cross multiplying. Finally we got like this, okay, 4 get cancelled. We got minus 1 by s square plus 9s plus 18. So this fraction will get s, 2 roots will get s plus 3, s plus 6 minus, so I of s. See here, minus 1 by 3 I return. Okay, why I return 3? You should analyze. See, 1 by s plus 3 minus 1 by s plus 3, s plus 6. Simplify this. In the numerator, you will get a parameter called 3. Multiply and divided by 3. Okay. If you multiply and divide by 3, so 3 and 3 get cancelled. So finally, so we get like this. This 3 and that overall the simplification gives 1 3. 3 get cancelled. So 1 minus 1 by the Laplace inverse of this one. So e power minus 3t, e power minus 6t. So please copy down the solution and then analyze. Okay. So from this, see what is our equation? A plus b. But A is not present in our solution. So directly B value is minus 1 by 3 e power minus, and then minus to minus plus C is, B and C we have value, A we don't have. A is 0, B is minus 1 by 3, C is 1 by 3. But you should enter 1 by 3 value, 0.333, and B value is minus 0.333. Next is Vc of S, voltage across capacitor. Okay. So this plus this, adding this 2, you will get a voltage across capacitor. 72 by s I of s plus 10 by s. 72 by s minus 1 by 3. Okay, what is I of s? This entire equation you take it down. Take all this entire equation here plus 10 by s. So 72 by 3, 24. Okay, into 72 by 3 is 24. 1 by s plus 3 into s. Okay. And minus 1 by s plus 6 into s divided by 10 by s. See here we return minus here, but minus 72 by 3 is what? Minus 24. Okay, this one I missed it here. Okay, got it. So Vc of s can be written as minus 24 into 1 by s plus 3 into s minus 1 by s plus 6 into s plus 10 by s. So minus 24. This 1 by s plus 3 into s represented like this, 1 by 3 into 1 by s minus 1 by s plus 3. If you simplify again, you will get same term only. Like that, if you simplify this, we will get same term plus 10 by s. Now group all the terms. minus into minus plus 3 by 24 by 3 is 8 by s plus 3, and minus into plus minus 3 by 24 by 3 is 8 by s. Similarly, minus of this one, minus into minus plus 24 by 6 is 4 by s, minus into minus plus into minus 26 by 26 by 6 is 24 by 6 is 4 by s plus 6 plus 10 by 10 by s. See, this 1 by 6 applicable for this one as well as this one. Okay, now group all the terms, all the constant, 10 by s, 4 by s, 8 by 10 plus 4 14 minus 8 6 by s, 8 by s plus 3 minus 4 by s plus 6. Take the inverse Laplace of this one. 6 by s is constant is 6, 8 e power minus 3t minus 4 e power minus 6t u of t. This is the voltage across the capacitor. Now this you can refer the standard question given in the problem. See, what is Vc of t? D plus e power minus k1t plus f e power minus k2t u of t. What is the value of d? Okay, d is 6, e is 8, f is minus 4, and k1 is 3 and k2 is 6. Don't write minus 3 minus 6 because they asked magnitude of k. Okay, got it? So by this I provided the solution for all the numericals asked in assignment 6 of NPTEL course network analysis. So have a nice day. Thanks for watching the video. So you copy down the entire solution, okay, so thoroughly, and then start analyzing. If you found any silly mistakes in the simplification, if any one value is wrong, your entire solution will be wrong. Okay, so therefore whatever I am providing the here notes, you just copy down in the book and then try to solve. Okay, if I done any some simplification mistakes, you can report to me. I will correct it so that everyone can get good marks in the end. Okay, so please don't blindly copy whatever the answers I am giving. Okay, even though if I know little bit about the subject, in simplification plus or minus everyone will do. So if any such things if you found means, you just inform to me, so I will correct it. So all the best for assignment 6. So submit the answers whatever I given in these notes. Okay, before submitting you should do it once. Okay, because same type of numericals will come for exam, only they can do data change 100%. They will do data change. You should able to do at that time. 3 hours exam will be there. If you are not practiced, you cannot clear the subject. Okay, so by that parallelly you should watch video lectures or whatever in the website. Okay, 50% numericals will come from watching the video lectures, and 50% numericals assignment itself in the main exam, and all those assignments questions they will ask with the data change. That's it. And 50% numericals, whatever the numericals solved in the regular video lectures. Okay friends, take care. We can meet you by providing solutions on assignment 7. Take care. Bye.